Okay, hello everyone, and welcome. We're going to review something from last year. We're going to solve linear systems, and today we're going to do it by graphing. Okay? Again, today's objective, to solve a system of linear equations by graphing, of course. The essential question, and you'll need this for the homework check, how can we use graphing to solve a system of two linear equations? All right, just a quick review. Guys, we looked at linear already. All right, it comes in different forms. A linear equation can be slope-intercept form, which tells you the slope and the y-intercept. But it can also be written in standard form. And there's other forms that they can be written in as well. These are all the same line right here. But a system of linear equations is when we have two or more linear equations working together. An example here, here's two linear equations. All right, you can try and figure out what the x and the y is here by yourself if you want. You can pause the video. Any ordered pair that makes all the equations true is a solution to the system of linear equations. But it has to make all the equations true. All right, one way to solve a system of linear equations is to graph it. And that's what we're looking at here today. Tomorrow we'll look at substitution, and the next day we'll start with elimination. Those are other techniques. But graphing is frankly, maybe the best way of all. All right, because it gives you a visual. Of course, sometimes it doesn't tell you exactly, but it gives you a visual of where the lines intersect, and that is the solution. If the two lines cross at one point, then there is one solution. If they cross like this. All right, if the two lines are the same line, all right, and that happens sometimes. It's a system. The lines are expressed in a different way, but it's really the same line. They're right on top of each other. All right, then there's infinite solutions, because every point along that line makes both equations true. All right, if the lines are parallel and never intersect, then there's no solution. If they never intersect, then there is no solution. All right, example 1 here. First, I'm going to use the y-intercept and the slope to graph each of these lines. Again, they're in slope-intercept form. So just use the y-intercept and the slope to graph both these lines. See where they intersect, and that's the solution. You can do it in Desmos. If the lines have the same slope, but different y-intercepts, then there is no solution. They have the same slope. All right, so they're parallel lines, but they're not one on top of each other. They're two different lines. They just have the same slope. There is no solution. If the lines have the same slope and the same y-intercept, then of course they're the same line. And the system itself has infinite solutions then. And again, any ordered pair that makes all the equations true is a solution. Okay, one solution, no solutions, infinite solutions. All right, I'll move down here. Now you can look at the homework check now if you'd like. It's open. And we'll take a look at it in class. These are the vocabulary words that we'll be using for the warm-up. All right, that's it. Thanks.